So tonight what we're going to do is we're going to finish up the second part of chapter 10, which talks about the namespace file. And then we're going to jump into 11. And Brendan has graciously said he would lead us to that discussion tonight. So what I'm going to do is I'm just going to turn it over to you to Brendan, and we'll go from there.
Okay, great. Yeah, thanks, Colin, and thanks for delaying this by a week, mainly because I wasn't able to show up last week. But I think I'm ready now for the most part. Okay. So to start, we'll be covering, it says chapter 14 here, but we're really covering, as Colin said, the last part of chapter 10 on namespaces, and then we'll be talking more about dependencies, which is in the following chapter. And so the objectives here are to describe the purpose of the namespace and description files and what exactly they are, to know the different types of dependencies, and I guess not when to use them, but how to handle them, and to understand the different components to a namespace file. So we'll be talking about what the search path is, the workflow involving it, and what imports is. And so I thought I'd try to mix things up because I'm in I think 3 other book clubs. And so I'm with Ryan for 2 of them, I think Advanced R and Master and Shiny. And one thing I like about those textbooks is that they have homework questions. And I don't blame our packages for not having any homework questions, but I feel like it really helps test your understanding. It's a bit ironic I'm saying that because I never do the homework anyways, but at least reading it, lets you reflect, or, forces you to really be honest with yourself if you understand what you're reading. And so the next best place I could go to is just Stack Overflow and see if there are any questions that what we learned in this chapter could potentially answer. And so it was hard to find good ones. So these ones already have accepted answers, but just for us to read through them quickly. And then, as we discuss this material, we can think about where exactly we might be able to answer these people's questions. And so the first one, I guess, is a more straightforward one. And so he asks, or this person asks, how to edit namespace with Roxygen when creating R packages. And so I guess I don't have to read all of this, but that's what this person is wondering, and how to use exactly the Roxygen package. And basically, to answer below here is just to read the R packages text. And so we'll try to cover that in this chapter. I'll put it in the chat. And the next one, it's a bit more difficult as well as wordy. And so maybe we'll just cover it at the end if we have time. This is actually a longer chapter, a longer section. But this relates also to namespaces. And it's where this person has a function that uses the match.function or match.fun, which lets you get the syntax or pull the syntax from a function. And so on loading the package, it can't find the function name. And so it's a problem that potentially relates to namespaces. And so we'll go through that again at the end if we have time, because I think it touches a bit on what we read in this chapter. Okay. So for section 10.4 is where we're introduced to the namespace file. And so it allows our packages to communicate with each other. So it lets you use functions from other packages, as well as where you specify what functions you want to make available to others. And so every namespace file contains a directive or different types of directives. And a directive describes an R object and says whether it's exported from your package to be used by others, or if it's imported from another package to be used by you and yours. So as I said earlier, imports controls which functions from other packages are made available, and exporting a function allows it to be used outside of your package. And so there are 8 namespace directives. First 4 describe different types of exports. And so there's export for just exporting functions, export pattern, export classes, and export methods for exporting S4 classes and methods respectively, and the S3 method. And maybe I just can't count because that's 5. But I'm pretty sure the textbook said that. So maybe they lump export classes and export methods together. And then there are the imports. So there's import for importing all functions from a package, importing selected functions, including S4 generics, and then import classes from and import methods from for S4 classes and methods. And so they didn't specify this one, but I added it in here. Used in lib to import compiled code from another package, just because in the example they give us from the test stat package, and in any given namespace file from any package, you'll see this used a lot too. So I think it's handy to be aware of that as well. And you can create the namespace file using the document function from DevTools. And so now we'll move on to the next chapter, which talks about dependencies as well as the namespace and description files in more depth. And so this talks about what your packages need, because dependencies are code that your package needs to run. So for the description file, this specifies what packages are needed for your package to work. And so they're necessary in order for your functions to do whatever they do. And on the flip side, your package will be a dependency for other people's package. And so namespace helps with this by specifying what functions or exporting functions to make available to others. The text specifies this is annoying but required if you're submitting to CRAN / if your package is going to be used by others. So for the next section, it's runtime versus develop time dependencies. And so there's the import section, which tells you which packages are required at runtime for yours to work. So this is what users are going to need to have as well of your package. So as an example, this is what it would look like. They're comma separated for each package. And so, for example, this one, this hypothetical package would need dplyr and tidier to run. And so packages listed in suggest are not necessary, but they may be used for, say, the developer or to unlock some other functionalities that are more optional. And so I have here, I just gave as an example, GT or withR, which the textbook specifies, can be used to run tests or that clean up after themselves, but actual users at runtime might not actually have to utilize this. And so the easiest way to add a package to imports or suggest is with the use package function. It's recommended to use tidy description as well regularly, just because it keeps things neat. And so it should be, or it's recommended to incorporate this into your workflow as well when creating your description file. And so for imports and suggest, load all checks that all packages and imports are installed, as I think we've discussed before. Adding a package to imports ensures it will be installed, but it doesn't mean that it will be attached along with your package. Or in other words, it's not the equivalent to using the library function. And we'll talk more about that later, about the differences between loading and attaching a package. So just be aware that it doesn't attach the package and automatically make it available for you to use. And so inside your package, the best practice is to explicitly refer to external functions using the double colon. So this is where you specify which package you're using for a particular function. And the text notes that I think there's a slight computational cost at 5 microseconds. So it only becomes really, that only becomes a burden, if you're to do that millions of times, but otherwise, this is best practice to be explicit and clear in which packages you're using. So for suggest, you might use suggested packages for example data sets, running tests, building vignettes, or maybe there's only one function that needs the package. And so packages listed in suggest are not automatically installed along with your package, which means you can't assume that it's going to be available. If you add packages to description with the use package function, it'll also remind you of the recommended way to call them. So we see that here in this line to refer to it, in this case, dplyr for some function. And so for the next section, we're going to talk about guarding the use of the suggested package. And so inside a function in your own package, check for the availability of a suggested package with required namespace. And so there are two basic scenarios in which you do this. So if the suggested package is required, this is what the code would look like. And so if we go through it line by line, it says if you require it, and if you don't have it, stop, and then it'll tell you that you need to have it in order to use this function. And then the second scenario is if it's optional, then you'll have a fallback method. So we see that here in the code as well. If you have a particular package, then you can use it. If not, then you'll fall back on some other default. And so just as an FYI, at least it's something I had to look up, the quietly equals true in the required namespace function, since they use it here, tells a function if it should progress anyways and suppress error messages, I think. And you can also use the rlang package to do exactly what I just described earlier. And so I think the syntax is a bit neater. And so you just use the check installed function to do what we talked about, either to see if it's required or to see if the package is optional, and then to fall back on some default. And so these rlang functions are handy for programming, and it's something that's recommended by the text, is because it allows for things like vectorization over your package, class errors with data payload. I don't know what this is, by the way, so someone can jump in to teach me about that, or for check installed. And so it'll offer to install the needed packages in the session. And the text also says that when there's only a few people within your package development team that might be using it, you could just import everything. You don't need to really worry about the suggested section. However, in most places, to use a suggested package, it's usually using an example or a vignette. And so here we often guard with require, but you'll also see require namespace used for this. Does that make sense so far? I've been talking for 16 minutes, but I'm not convinced that I haven't made a mistake within these past 16 minutes, so feel free to stop me at any time. Okay, and so for the next section, we'll go more in depth on whether and how to guard in a test. And so tidyverse team doesn't usually guard the use of suggested packages in tests. In general, for vignettes and tests, they assume that all suggested packages are available. And they say this is done only for pragmatic or convenience reasons. But even then, they make an exception and guard the use of a suggested package in a test. So here's a test from ggplotsu, which uses the skip if not installed function to skip execution if the suggested SF package isn't available. And so we see that here. And so the function still works fine if SF isn't installed. And the SF package in this case can be non-trivial to install, and it's conceivable that a contributor would want to run the remaining tests even if SF isn't available. And so I guess one question I have for the group is what examples or personal experiences you might think of where you might run into a similar situation of either using skip if not installed or something like that. Because I'm just trying to think about ways, while I'm in the very, very early stages of package development, how to apply what I might read. The only example I can think of that comes to mind is if you're using a package like, I think if Rex is here, I know you use BRMS and probably use Stan. That's rstan is a package that requires your R installation have compiled C++ code. And so let's say you're making a vignette that uses rstan, that might be a lot of work if you require users to have that package installed. So that's a case where skip if not installed might be very useful. Other than that, I'm not sure if there are other examples where installing a package is particularly non-trivial.
I guess my thought is, like, potentially if I'm thinking of like packages that have it was kind of along the same lines that you're saying with like the C++ and the compile code. Is like if it's a package that requires it has a significant amount of dependencies to it, and the thing that's going through my mind is like like, oh, why can't I think of it right now? But like mapping stuff has a lot of dependencies. Like some of those packages have just a ton of dependencies behind it, and so you may not require your developers to install all of that just to run one single test. And so it's like, skip it if you don't have it, because maybe you offload that specific test to your, and I'm taking it to a testing place, but you can do this for vignettes when you build it, whatever you're building your website for your package, you might offload that to your continuous integration, continuous development. And so basically it's like that environment has your dependencies loaded, but when you're in like a local development portion of it, then you skip that test. But then once it gets pushed into like version control, that environment has all the dependencies and it runs all of it. But that's like what's running through my head right now.
Right. Yeah, I think that makes sense. I guess at least when I first got the question, I thought it was a good question, but it's not that hard to play that there's some packages with just many dependencies. So you're right, much they just make sense.
Yeah, I'm thinking along the same lines as dependencies, but dependencies, some packages may have dependencies outside of R, like some system dependencies that you may not always expect everyone to have.
Right.
I mean, I guess one like example that I could think of, but it's not that complicated. It's a simple dependency, but something like that, where as in meter requires you to have pandoc installed, which is not an R dependency, but a system dependency.
Mm-hmm. Right. Yeah, it's a good point. It's only something, honestly, that I was aware of very recently when reading this chapter, because there's a small section where they link you to a blog post where they talk about all the different kinds of dependencies there are, as you pointed out. And so maybe we'll discuss that more later too. Yeah, all right, thanks for that. And so for the next section, we're going to talk about minimum versions, which is also a section that I think we've talked about before in a sort of in a different context. But if you need a specific version of a package, you specify it like below. So under the import section, so in this case, you need a version of dplyr and tidyr of at least 1 or 1.1 or greater. And so you always want to specify a minimum version rather than an exact version. And I think we had a conversation about if you could flip it the other way and have a maximum version rather than a minimum. And so that was pretty interesting. But they don't comment on that. They just say don't set an exact version, because it's just more likely to be problematic since it's a more specific condition, and if your users don't happen to have that exact version. And so, as it says here, dramatically increases the chance of conflicting versions. And so, I guess it's the way they talk about it in the text. It's a bit more of an art rather than a science to determine what the minimum version should be, although they give some, I think, concrete and handy guidelines. So the safest thing to do is to require a version greater than or equal to the package's current version that's on CRAN. But it may be very conservative or inconvenient, especially if your package can use even older versions of the packages it depends on. And so in the absence of clear hard requirements, you should get minimum versions based on your expected user base And so the package versions they're likely to have, and do some sort of cost benefit analysis of being too liberal versus conservative in the minimum versions you require. And so the de facto policy of the tidyverse team, at least, is to specify a minimum version when using a known feature or a known new feature, or when someone encounters a version problem when using it, and I guess reports it or makes an issue on GitHub or something like that. And so when managing package versions, they talk about using the renv package, which supersedes, or I guess is the new pack package for allowing you to reproduce your code in situations like that, and when dealing with the minimum versions of packages. And this is just an aside, but I know there are probably others out there, but things like the groundhog package I know is primarily oriented for data analysis. So it shouldn't be used for package development, but this also allows your scripts to be reproduced if you run them, say, maybe years later, and all the other packages are updated. So it sort of allows you to freeze your environment, as it were. And at least at one point, I could see why this would be very useful for like the tidyverse. I know for a while, a lot of people are sort of mad at the tidyverse. Like, it felt like at one point every second the function was being deprecated or something. I think Hadley had a whole presentation on how to deal with that sort of thing when I was at the 2020 conference, but since then I haven't really run into that issue. So that's a case where these sorts of things can be useful. Oh, and just to talk about the renv package, I guess, in a bit more depth, even though I haven't used it extensively, it allows you to sort of take a snapshot of your environment. And so if you continue working and then something goes wrong, you can default to that previous state. And so for other dependencies, we'll talk about depends. So depends used to be the only way to depend on another package. But now, despite the name, you should always use, or it's recommended to use, imports. You can also use depends to state a minimum version of R itself, but you have to be very careful. There's linking to, so if your package uses C or C++ code, you need to list it here. And then there's enhances. And packages listed here are quote unquote enhanced by your package. So this means you provide methods for classes defined in another package. And so sort of the opposite or reverse of suggest, but it's hard to define what that means. So they don't recommend using it. So I guess we can just forget about that. And for the next section, we'll talk about an example of how easily an R version dependency can creep in and have a broader impact than what might be expected. And so they talk about the save RDS function, which writes a single R object as an RDS file, which is, as people here know, an R specific format. And so for many years, RDS files used the version 2 serialization format, but in 2019, version 3 became the new default in R version 3.6. And so now it can't be read by R versions prior to 3.5. And so this becomes a problem because if that gets regenerated with a modern R version, by default, the new RDS file will have the version 3 format instead of the version 2. And so it gives you a warning here to let you know about that. So all packages listing the original package in imports, or even suggest, have to varying degrees inherited this new dependency. And so you have to be very deliberate about the version of the RDS files you're using until R versions prior to 3.5 have fallen off the edge of what you intend to support. And they also note that similar issues can appear in C or C++ code. Does that make sense? I thought this is a good case example, but I don't know if I explained it clearly. Okay. And so for the next section, we'll talk about non-standard dependencies. And so the remotes field can be used when you need to install a dependency from places other than CRAN or non-standard places. And so the way to specify various remote sources is described in the DevTools vignette, which I forgot to link, but it's in the text where they walk you through this. And so if your package relies on a development version of UseThis, the description fields might look like this. And so the key thing to look at here is that when you do that, the version number will be updated. But you have to make sure that when you submit to CRAN, that it's not in this intermediate state. Meaning that with the remotes field and with the dependency required, sorry, I was just reading off this. So it's important to note that you should not submit your package to CRAN in the intermediate state, meaning with the remotes field and with the dependency required at a version that's not available from CRAN or Bioconductor. So that includes GitHub. And so you have to make sure that it's available from CRAN or Bioconductor. You may also see DevTools develop packages with packages listed in description fields in the form of config needs. This pattern takes advantage of the fact that fields prefixed with config are ignored by CRAN and also do not trigger a note about unknown, possibly misspelled fields in description. And so the most common example is the pathway config needs website, which provides a place to specify packages that aren't a formal dependency, but that might be present in order to build the package's website. So there's an example below of what might appear in description for a package that uses various tidyverse packages in the non-vignette articles on its website, which is also formatted with styling that lives in the tidyverse / template GitHub repo. And so that's just shown here. And so the config needs convention is handy because it allows a developer to use description as their definitive record of package dependencies, while still maintaining a clean distinction between true runtime dependencies versus those that are only needed for specific development tasks. And so for the next section, we'll dive more into exports. And so if you install a package you created, load all functions with load all and reload all RStudio, you'll notice that no functions are available. And this is because none of them have been exported, which means they're not usable outside of your package. And so we export it by using the following, which Roxy and Sue should provide a template for. So generally, it's better to export too little than too much. This is because if you make all of your functions available, the text notes that it might be harder to take away these functions if people get used to using them. And so to be more conservative in what functions you choose to release and share with others. But if you're creating a package for yourself, you can go crazy. And so I was just talking about how I didn't read the blog they linked to on when you should take a dependency, which probably is pretty important because this chapter is about dependencies. And we talked about it earlier about the different kinds. But if people haven't covered it already, I'll put it in the chat later. Because my computer is just not behaving. I can't find the window. But anyways, I'll get back to the last section, which is on namespaces. And so I think I've defined it a few times before, but again, it allows your packages to communicate with each other. And so you do this using imports and exports. And so an example here. So this is an example of utilizing the namespace or being able to look up an object using its name with this double colon operator that we talked about before. And so it allows you to disambiguate which function you want from a particular package. And so the text just talks about how if you're to create your own function like dim, and so in this example, this function just creates a vector of ones, of 2 ones. If you end up using the function nrow or ncall or any function that depends on the dim function, it won't be a problem at all. And so this is because of namespace. And so what it does is that when you use a function like nrow, it searches for the package or searches for the function dim in the base environment and not the one that we just created in our global environment. And so exports helps you avoid conflicts with other packages by specifying which functions are available outside of your package. Internal functions are available only within your package and can't be easily used by others. And you want to export a minimal set of functions. The fewer you export, the smaller the chance of a conflict. So for the search path, it's a list of all the packages that you've attached. And for loading versus attaching a package, loading a package makes it available in memory, but because it's not in the search path, you won't be able to access its components without using the double colon. But if you do use the double colon, it becomes a bit confusing because it'll automatically load the package for you. So packages are rarely loaded explicitly, but you can do so with using require namespace or load namespace. In contrast, attaching puts the package in the search path. You can attach a package without first loading it. So both library or require automatically load the package for you before attaching it. And you can see the currently attached packages with the search function. And so for the code here, it shows that using the double colon doesn't attach test that to the search path. So if we look at test that, we see it doesn't appear in the search path later. But attaching the test that package that's in the search path requires using the library function. And so I guess one thing, because I know that I'm probably not going to remember it after this book club is finished, but just any ways that people try to distinguish loading versus attaching a package, whether it be a mnemonic or something else, because I can see myself confusing the two terms just because, at least semantically on the less technical level, they seem pretty interchangeable. And I've definitely always used it that way. Like when I think of library, I've always said, it loads the package, but it actually, it attaches it. Or do people just figure it out? Or it's not even really relevant to when you're programming most of the time?
I think the best way I've had it explained to me and that I kind of share, and I use this more for like the data analysis portion about installing versus attaching, is the idea of like your phone and mobile applications. So like what you do is like when you install it, you go onto the app store, you get the app, and then you install it onto your phone. Now, is that application open? Not yet, until you actually physically click on the open button, then you open it. Then it's in memory, it's attached. And so you can access it in memory, is the way that I kind of think of it. I don't know if anybody has any other ones, but I found that one to kind of be it helps grasp it a little bit more, but.
Yeah, that makes sense to me.
Would it be maybe like it's available in stored memory, but you're not actively using it yet? So like, I'm thinking like if you go to your packages tab in RStudio, there's a whole bunch of these values that aren't technically checkmarked because they're not loaded. You're not actively using them. They're not part of the active workspace that you're dealing with. And when you attach that library, it makes it accessible for accessing the functions, et cetera, kind of the dispatching piece of this, the S3, S4 concepts. Loading it just makes it available on your computer. Am I misunderstanding the load namespace? I've never used that function before, and so I'm apologize for not being familiar with how that actually works.
Yeah, no, I think, or to me, it sounds right. And so, I mean, I guess the table doesn't really, the table here specifies which functions correspond to which. But yeah, I guess, at least for me, I'll have to probably refer back to text like this just to make sure I have the two.
Well, so like when you
separated correctly.
When you do like a DevTools load all, is that the same process or the same objective of what load namespace would do? Because it's not technically attaching the library, right?
But it's
No,
accessible.
it doesn't make it available. Yeah.
I think it is, isn't it? When you do load all, can't you just run those functions directly? It would just be like running library.
Well, because the load all is accessing the description folder and it's pulling all of those dependencies in, right? It's making it available. It's like you're making the library call, attaching the library to your search. But if you've downloaded it but not completely accessed it, I'm looking at that as being it's loaded, it's accessible, but you're not actively pursuing it. And kind of what Colin was mentioning about the phone concept. You've downloaded it from its library, its repo, wherever. It's on the phone, but it hasn't been allocated memory yet. You haven't accessed that space yet. And a good example of that, if you ever drop in and look at all the open apps that you have on your phone, or close those so that you get some resources back. The differences between load and attach. It's available, but it's not being accessed yet.
On the using like require namespace, I've used that before when I want to check whether a package is available before I do something and let that guide the process. I've used it within a package before because you also can't obviously run library within package code because that's changing like the environment for the user. But to know whether a package is available, you can do require namespace. So like in this plot method, I sort of check whether the cow plot's available by doing require namespace. If it is, then I do the making the grid with all the plots. If not, I don't.
And that starts on line 39 of your example, correct? Is where you start to use that require namespace.
Yeah. So I sort of determine all the settings, and then that controls what plots that actually made and how what's returned from that function.
So basically what you're doing is you're using require namespace to get your true false for your conditional statement, basically.
Yeah, but then
That's why you're
all the
using it.
functions are still accessed with the double colon because you can't load it into, you can't attach those packages.
That makes sense. Okay, I understand the require namespace portion of it, that it loads it and it still makes everything, available. I guess the require one, I don't totally understand yet. Does that just take it the next step forward and then like add those packages to the search path? Is that what it's doing?
I think it does. I just remember reading a blog post which pretty much said there's no reason to use require over library. I'll try to find it. But ever since then, I was like, just forgot what it did.
That's the adage that I've always remembered, like ever since, like, I think even in R for DS, it says it somewhere, like R for DS somewhere says something like, yeah, requires is available, but don't use it. Like, it's like one of those first things, like it's available. And I guess, I don't know. maybe it's just something that's been brought over in libraries like the new, or the accepted
Yeah, I
format to do
only
that.
ever see it in like really old Stack Overflow posts now, right? Because it's just sort of fallen out of fashion now. Yeah.
It must do
Sure.
something. I'm just wondering if it has to do something with the search path. Like if there was an update somewhere where library was introduced that it did something for the search path. Because I think that's what's foundational to this entire conversation is like, how does it affect the search path? Like if it does or if it doesn't. And like I suggest one thing that's eye-opening for me is I have other people develop code that sends it to us that aren't as experienced, and they'll sometimes put library inside of their functions. Just do it one time and see what happens. And it's kind of eye-opening to see what actually happens when you do put library inside of a function and you do a load all. You can see how that affects your search path, and so you can kind of see why the adages don't do it. So break your code a little bit and just put library in your function and do a load all and see what happens. Do library tidyverse, because that has a lot of messages in it. See what happens. It's a good experience. So some good conversation after I saw that a couple times. So
Okay. Yeah. Well, will do. Okay. Yeah. Great. Thanks for that correction. And so yeah, I'll look into load all and the documentation, try and understand it better as well. And so I think as what we already talked about, I don't know if in the text they explicitly say never use require, but I've heard that before too. But they do say use library and data analysis scripts generally, and that's preferred, but to never use it in a package. And to use require namespace inside a package, you want a specific action, depending on whether or not a suggested package is installed. And so you never need, okay, yeah, right in front of us, you never need to use require. Require namespace is almost always better, or load namespace, which is only used for internal R code. And you should never use require or library in a package. Instead, use the depends or imports fields in the description to specify what packages you want. So what's the difference between depends and imports in the description? And when should you use one or the other? So listing a package in either depends or imports ensures that it's installed when needed. The main difference is that where imports just loads the package, depends attaches it. Other than that, there are no other differences. And unless there's a good reason otherwise, you should always list packages in imports, not depends, which they talked about earlier. This is because a good package is self-contained and minimizes changes to the global environment, which is what you would potentially change by putting it in the depends. And so we want to minimize changes to the global environment and the search path. So for workflow, generating a namespace with Roxygen2 is just like generating function documentation with Roxygen2 that we've covered. Use Roxygen2 blocks, starting with the hashtag or number sign or pound and tags. The workflow is the same. So adding Roxygen comments to your R files, using the document function to convert Roxygen comments to RD files, and then look at namespace and run tests to check that everything's correct, and then you repeat until all of the functions you want are exported. So for the last section, I believe, on imports, namespace also controls which external functions can be used by your package without having to use this double colon. So both description and namespace seem to be involved in imports. So as we covered earlier, description has an imports field, but namespace also has these import directives. And so we see that for each file. I can't remember which packages I borrowed these from, but they both utilize some sort of imports. But this last section makes sure to distinguish between the two because it's just an unfortunate choice of names. The imports field really has nothing to do with functions imported into namespace. And right now we're talking about the description folder. It just makes sure the package is installed when your package is. So it doesn't make functions available. You need to import functions in exactly the same way, regardless of whether or not the package is attached. Another note is that depends is just a convenience for the user. If your package is attached, it also attaches all packages listed in depends. If your package is loaded, packages in depends are loaded, but not necessarily, but not attached. And so you need to qualify functions with a double colon again, or specifically import them. It's common for packages to be listed in imports in description, but not in namespace. But the reverse isn't true. So for every package you mention in namespace, it has to be present in the imports or depends field of your description. So for our functions, if you are using just a few functions from another package, you should note the package name in the imports field of the description file and call the functions explicitly. This is a common theme using the double colon. If you are using functions repeatedly, you can avoid doing this by importing the function with import from. And so that would be in your description field, I think. If you're repeatedly using many functions from another package, you can import all of them using import. This is the least recommended solution though, because it makes your code harder to read. You can't tell, and it's because you can't tell where a function is coming from. And if you import many packages, it increases the chance of conflicting function names. So this is just an error on my part. I think I was supposed to turn these into like code snippets. But yeah, that is all there is on namespace and dependencies for these two chapters, or chapter and a bit. So I'm happy to try to answer any questions or discuss it in more detail. Oh, and by the way, since I presented the Stack Overflow questions related, the solution to the first one is kind of obvious. I guess to with the document function to just use this to export, or if you're importing functions. For the second one, I don't know how well it would work because I realize the question is actually quite involved unless we were to all read it in silence. But I urge you to check it out later because if I remember why I pulled this question, there's an issue with scope and with exporting functions properly, which I discussed in the last section. So if you want to try to check that out later on your own time, you're free to do so. I found that when I'm learning a new, usually a stats concept, I try to look up issues on cross-validated relating to it to really test my understanding. And so I'm trying to apply that with the R packages chapters just to make sure I know what I'm reading or talking about, which isn't always the case, but I try.
Excellent. Thanks, Brendan. I really appreciate that. It's a good point to look at the Stack Overflow and see if you can answer some of those questions, because that's definitely a good tip. I need to incorporate that some more. I did want to add, I was kind of digging while you were talking there a little bit about the difference between why require or why you shouldn't include library require in your R package. And this Stack Overflow actually had a good answer to it that kind of made sense. It's the idea of like having conflicting names. Like if you put a library call into your package and a user has a library it attaches a library that has a specific function and then attaches your package, and then you have a similar function name, your function's name is going to overwrite what the user's expectation is. And so this Stack Overflow description had a really good reason why is like filter, right? You could have like stats filter from the stats package or filter from the stats package, but then you do like a library call, like library dplyr with inside of your package. What's going to happen is that function definition for filter for dplyr is what's going to be in the R landscape. So anytime that the user calls filter from then on in their analysis, you've changed it and they have no idea why that's the case. And so I'll post this in the chat, but I guess it doesn't answer the total question about like, why the difference between library and require, but it answers the question of why not to put library call into your package. But see you later, Rex. So any other questions, comments that people may have? All right, cool. Well, I do just kind of want to quickly highlight like where we're kind of going next, like what the roadmap kind of looks like. I'm going to share my screen here. See what the group thinks. Can everybody see the sign up sheet? Okay, sweet. Let me bump it up so everybody can see it a little bit better. So I'm really thinking that maximum, we only have about 3 weeks left. I think within the next week, we can do chapters 18 and 23. I doubled up some chapters because honestly, some of these chapters that we have left are like really kind of short, except for our command check and releasing to CRAN. That one's probably a little bit more extensive, but other markdown files and lifecycle really isn't a lot. The third week, I put a question mark, mainly because the website chapter is yet to be complete and continuous integration is yet to be complete. So I put a maybe there in saying that, well, we can probably end on the third and see if the chapters get done. I don't know if they will, or if somebody in the group has like any interest or any experience doing this stuff and maybe would like to just, I don't know, share their experience.
I was going to jump into that chapter 19 and 21, although the chapters aren't finished, just touch on CI/CD process and kind of the concepts behind how you manage that from a Docker image concept or a was it GitHub? What's the name of that? It's GitHub Tools, GitHub something. The process used to be Travis CI. If that's okay, but Rex already left, and I was going to ask if Rex wanted to collaborate or if he was interested in that chapter. Do you intend on Rex doing the R command check or releasing the CRAN since he was on that older chapter section?
If he's willing, I could reach out to him and ask him if he's willing to do it. I mean, I don't want to put him on the spot, especially if he has other responsibilities. Agreed. But
agreed.
Yeah, I mean, because I think he has the most experience for submitting to CRAN, but I obviously, want to ask him and see if he'd be willing to do that. But like, I'm happy to do like next week with the other R markdown files and lifecycle. Like, I don't think that's going to take too much time, and it's pretty straightforward information. Our command check is probably more involved. The continuous integration stuff, I mean, if you have interest in it and you have experience in it, so if you want to talk about it, yeah, there's just no content in the book to
Correct.
work from. There's like 2 sections.
Yeah, it's kind of ephemeral at the moment. No, I've only done it successfully once, and it was on some weird slide deck thing that I was doing. I haven't used it from an R Studio perspective yet, or from an R perspective yet. But I would like to give it a shot and see kind of where that takes us. Maybe it'll be a shared experience of my failures, if anything. But it's of very much interest to me. The whole concept of CI/CD is very interesting.
Yeah, I mean, if you have interest in it, I just wanted to kind of highlight that we're really close to being done, in all honesty. So literally probably 3 more weeks and then this book will be complete. So but I just want to kind of highlight the road kind of moving forward with the group. And if anybody's interested and if Rac's not interested in the R command check, or if has other responsibilities or something, if somebody else wants to jump in, or if somebody wants to take the other markdown files too, like just let me know. I just put my name there.
Our book club is fairly late in the evening for the most part. With our studio conf going on next week, the date of the 27th, Wednesday, the 27th, do you see that conflicting with anything or of any of the team, the other cohort members having any issues with that?
That's a good question. Does anybody have any conflicts, or do we want to delay next week for another week?
I don't have any conflicts personally.
Yeah, me neither.
Okay, well, I think we should go. I was gonna go, but then at the last there were some changes. There's some changes leadership wise and stuff. So I've decided to leadership wise as in our organization, and so I decided not to go this year. And so I was gonna go, but then opted to save some money for next year. So, but I have no conflicts as of right now. So. And like you said, it's pretty late in the evening, so I don't think it should be too much of an issue with some of the sessions that are going on with people, because I think they're streaming some of the sessions. So, so I say we probably just push through and get this done, because literally we have 3 weeks left, and I think we can get it done in 3 weeks. Because I'm already starting to plot and scheme and think about what my next book club's going to be. So I'm itching to do something a little different. So any other questions, comments? All right, cool. Well, I hope everybody has a good night. I'll see everybody next week, and then see each other in Slack. Talk to you later.
Thanks, everyone.
Thank
Great
you.
job, Brendan.